Alright, so today we're going to apply some of the things that we know about similar triangles to solving them in real world contexts. So if we take a look at number 1, it says to measure the distance across a pond, a surveyor locates points A, B, C, D, and E as shown. What is AE to the nearest meter? So A to E, that's what we want to find, that's our X. Well, if they're drawing a line straight across from here DB and here AE, that means those are parallel. If those are parallel, that means we have two similar triangles. This one here is similar to the whole big triangle by angle similarity from those angles being corresponding and this overlapping angle C. So when you go to label the little triangle, you can label the left side as 5 m for meters, the bottom is 5 meters, and the right side is 4 meters, according to the picture. And we're looking for the bottom of the big triangle, XEA. We don't know all of CE, we're missing this part DE. So the whole other side of the triangle is 4 and 8 together, so that would be 12 meters. From here, we're going to have to set up a proportion to solve. Doesn't matter which side you start with, but if you notice that the 4 and the 12 are in corresponding parts, and then you have the 5 and the X are in corresponding parts. So just make sure you put those together in your proportion. So that would mean your proportion could look like 4 over 12 equals 5 over X. And as a reminder, your numerators should be from the same triangle, and the denominators, the bottom, should be from the same triangle, which they are. So when you go ahead and cross multiply, you'd multiply the 4 times x to give you 4x, 12 times 5, but equals to 60. Divide by 4 to get x alone, so x would be 15. The only thing we're missing is the meters. All right, let's take a look at the second one. It says if the length of AB is 50 inches, so from A all the way to B, that whole thing is 50 inches, find the value of x. So x is here in our picture, which means if we're given something about this, we could figure out what the length of AK is. If this whole thing is 50, and we are given that this portion is x, we know that what we have left over is the whole thing minus what we're given. So this section here is going to be 50 minus x. Now, something else we can mark on our picture, if you noticed with our two triangles, is we have vertical angles here. And the two triangles that we have in this picture is this little orange one and this green one. And those are similar by angle similarity. So we're going to have to list the corresponding parts in the proportion. We already can see that 50 minus x and x are corresponding, but what side is corresponding with this 15? Well, it's not the 40, because 40 is the whole thing. We just want this portion of the orange triangle, which would mean if we look at the 15 and that's over here, wouldn't that also have to be on this side, 15 inches? And if we know this part is 40, wouldn't the orange part have to be 40 minus 15, the difference here? If you do 40 minus 15, that gives you 25 inches. So that's the missing portion of your triangle. So when you go to set up your proportion, we know that 50 minus x and x are corresponding. So we can put them in the same proportion, or the same fraction. 50 minus x over x. If I started it off that way, I would have to continue with the orange triangle, making it 25 over 15. You'll get a decimal for that one, but I want you to go ahead and solve yourself that one, and make sure you put whatever you have inches as your answer. As we continue, make sure you're doing these yourself. But like taking a look at number 3, it says a 40-foot wire held an inflatable T-Rex to the house and the ground. From the house to the T-Rex, the wire is 10 feet. If the top of the wire is attached to 25 feet up on the house, how tall is a T-Rex? So let's label our picture. It says a 40-foot wire held an inflatable T-Rex to the house and the ground. So the house and the ground, that is 40 feet. It says from the house to the T-Rex, house to the T-Rex, the wire is 10 feet. And then it says if the top of the wire is attached 25 feet up on the house, so up on the house, that's this side here, 25 feet. How tall is the T-Rex? How tall is the T-Rex? That's that side here. So you might be seeing our 2 triangles form here, this one here, and I'll draw them separate, that one, and then the whole big triangle there. For the orange triangle, you can see that this is the T-Rex. We can label that as X. But then the hypotenuse, that's a little, well, that's blank according to our picture, but we know the whole thing is 40 and this part is 10, which would leave 40 minus 10, or in other words, 30 to go here. So that's going to go on our label for the orange triangle. For the big triangle, we know the hypotenuse is 40. And the height is 25. That's the height of the house. So you'll use this picture to set up your proportion. So you can go ahead and try that out. And pause the video. Make sure once again you'll have x equals something feet this time. And then like taking a look at number 4. Ben is sick of worrying about his neighbors spying on him from their house. That's kind of weird, but let's keep going. He wants to build a fence high enough to block their view into his living room. He takes a few measurements and makes his drawing below. So this is his drawing. He has top of his neighbor's window, his fence, top of Ben's window, and you can kind of see a more realistic picture of what it could look like here. But it says, how high does he have to build his fence? So this whole thing is his fence, and that's what we need to find. But if you notice, there are 2 triangles here, this one, and once again, the whole triangle, and those are the ones that we need to focus on. So we know that, and if we draw them separate, the whole big triangle and the little triangle, we can see that from here to here is 15 feet. So I'm going to draw that in, label it. And we can see this whole side is labeled 35 feet. And with our 2 triangles, we can see that this whole side is 28, but that's not the part of the bigger triangle. If we look over here, this portion is 10, which would make that side 10 feet, which means this part is what the difference is between 28 and 10. So on that side, it's actually 18 feet. 18 would go here. So the part that we need is the height of the fence. This, I'm going to put an X here. That's the part of the triangle that we need. But if you notice, this is X and this portion here is 10. So whatever we get as our answer for X, we're going to have to add 10 to it to get the height of the fence in total. So why don't you go ahead, solve for whatever you get as your X, and then remember to add 10 to that, and that will be your final answer here. Okay. Last but not least, I want you guys to try this out yourself. One hint here, though, is when you go, one thing, add parallel lines. Sorry about that. And then when you go to add your sides together, make sure you do y plus 10 plus 8, in other words, y plus 18 there. Okay, go ahead, try those out. To double check your answers for the second one, you should have 18.75 inches. For the third one, you should have the same thing. That won't always be the case. For the fourth one, you should have 17.71 feet. Make sure you can do that math, get that answer. And then last but not least, for x, for this one, you should get 6, and y, you should get 2. So go ahead, try these out, see if you can get them yourself. Good luck!